All right, let's do a few more. Okay, now 3 is going to have both number and variable parts that we can factor out. So 16 and 12, what's the biggest number we can take out there? 4. So I can divide both of those by 4. All right, for my variables, I could divide by 2 x's. So I'm going to have x squared with both of those. It's going to be whatever your lowest exponent is for your variables, right? And there has to be a variable with every single term for you to do that. So if you have like a plus 10 on the end, then you couldn't do it for this problem. All right, but both of these are divisible by 4x squared, so I am going to put the 4x squared out front, and then I'm just going to do my division. So 16 divided by 4 is 4. I had 4 x's, I took 2 away. That left me with x squared. Over here, 12 divided by 4 is 3, so I'm going to get a minus 3. The x squareds cancel, so you just have a 3. There. And I'm not going to write it on every one, but if you multiply this back, it gives you what you started with. Who is it? Hello? Yes, thanks. Hannah, you are leaving. We're going to do this worksheet here in a minute. We'll probably finish it in class. And we'll probably start with your notes right there. I'll record. I'll probably put it all in one recording so you'll have to fast forward through this stuff you've seen. Okay. All right, what can we factor out for the next one? 3. All right, what else? A 3 and an x. All right, so if I'm dividing all of those by 3x, I've got to write the 3x out front. Make sure you don't forget that. A lot of times students forget to put that, to write it out front. So 18 divided by 3 is 6. How many x's are with that? 2. Then I've got 3, and I'll have x to the first power. What do I get here? What's 3 divided by 3? 1. And you had 1x and it was taken away. So a 1 has to go there. What I see students do a lot of times is those cancel out. And in a way, yes, they do cancel out, but they cancel out to be 1, not 0. So you got to make sure you have that plus 1 on the end. Because if you don't, when you multiply it back, you'll just get the first 2 terms. You won't get that last term. So make sure you put, if you have something that you're pulling the whole thing out, you're dividing by the whole thing, you need a 1 there. Okay? All right, you can factor things out that have more than one variable. So let's think about the numbers first. 2, 8, 7. Do we have any number we could divide all of those by besides 1? We do not. But we do have, we've got an x squared, an x squared, and an x. So you're going to take the lowest number of each variable. So I just have a single x with that last term, so I can only take an x to the first power. And then my y's, I've got y to the third, y to the fourth, and y squared, so I'm going to use y squared. I've got to use the lowest exponent for each one of those. So, Anya, whenever I do that, the number won't change. Oh, wait, first, I about made the mistake that I've been warning you guys about. Make sure you write xy squared out here on the outside of the parentheses. So I'll have this 2 right here. And then for my variables, how many x's am I going to have, Anya? 1. And how many y's? 1. Very good. So you're just like subtracting. You had 2. You're subtracting that 1 away. 3. Subtract that 2 away. So we got 2xy. And then we'll have 8. Riley, how many x's do I have for the second term? I had 2. I'm taking one away, so I got x. And then how many y's do I have? 2. And then, Isabella, for the last term? Very good. Okay, questions there? All right, we just got a couple more, and then I'm going to let you guys practice on your own. Okay, for number 6, Blakeland, with 8x minus 12, what number could I divide both of those by? Okay, a 4. So we're going to have 4 out here, which will leave us with a 2x minus 3. All right, what about 7? Okay, 1's the only thing that I can divide by. What about x's? They don't all have x's, so I can't pull an x out from this one either. I put this one particularly on here because I can't remember if it's on the worksheet I'm giving out today because I can't remember if I made a new worksheet. But I know I used to have a worksheet where there were some problems like this that just wouldn't factor. There was no GCF. So sometimes that happens. Sometimes there's no greatest common factor. And what you can write for that is prime. This is, everybody know what prime means mathematically, not those expensive, stupid sports drinks that my kids want me to buy them all the time. Yeah. Yeah, not that stuff right there. Okay, a prime number is only divisible by 1 in itself. So a prime expression right here cannot be broken back apart, right? It can't be divided by anything there. So you could just say that that's prime. Okay, all right, questions? Factoring trinomials. And I already told you guys that sometimes factoring is a part kids have trouble with. So teachers have came up with a million different ways to factor. GCF, which we just did, is not optional. You have to do it. There's pretty much only one way to do GCF. But factoring binomials, there is the method that I'm going to teach you. Then there's factoring by grouping. There's the X method. There's all kinds. That's what Miss Martin was doing back there. There's just all kinds of different ways that teachers come up with to try to teach students to factor. I just like the good old-fashioned way of teaching. I am probably going to show you Miss Martin's X way back there after I've shown you my way, mostly because some of you may have Miss Martin for math too, and that way you'll be familiar if she works those problems out that way. And you might like the X method, so you may want to use it, and if you do, that's fine. I don't like it, and I think that at a higher level of math, you should not use that. But it'll be fine if you do want to use it. So I'm going to teach this differently than I teach almost every other thing. Normally, we start off with notes, and we do a really easy problem and a couple more easy problems. And they get a little bit harder and a little bit harder and a little bit harder, and then by the end, they're pretty difficult, right? That is normally how I teach most everything that I teach in all of the subjects that I teach. Factoring is the one time that I start with the hardest problem. And the reason that I start with the hardest problem is if I start with the easy problems, a lot of times students make assumptions that are not always true for all problems. So we are going to start with the hardest problem. So if you can understand how to do this first one, you should feel pretty good because it's not going to get any harder than this. It's going to be about the same. So factoring is the process that reverses multiplication of binomials. And so a problem will look like this: factor 12x to the third minus 14x squared minus 40x. And so the first step in factoring is going to factor out the GCF if there is one. And so we just did GCF, and if we look at 12x to the third minus 14x squared minus 40x, Aiden, what is the GCF for that expression? What? Let Lanaya take over. What is it? It's 2x. Good. So we're going to have 2x. And so you always want to check for GCF first. We're going to do a lot of problems that do not have GCFs, and you're going to forget, you'll start to forget to check for GCFs. But you always want to check for a GCF first. So if I factor out a GCF, I'm going to have 6x squared minus 7x minus 20. Okay, now this 2x that we have pulled out here now is done. We're just leaving it out front. What we need to do now is we need to take this other part, the 6x squared minus 7x minus 20. We're going to see if we can factor it further, okay? Because on the worksheet you just did, I don't know if those would have factored further or not, but I didn't want you to worry about it because we were just working on GCF there. But on these problems, there's going to be likely that they will factor even further. There's no more GCFs. You can't pull anything else out of that. But what we're going to do is factor into two binomials. So our goal is to have something that looks like this. We'll have like our 2x will stay out front, but then we'll have like a set of parentheses here and here, and we might have something like x plus 3 and x minus 7, except for that's not going to work because that won't give us what we're supposed to have. But that's what we're working towards. We want to break it all back apart. So, if you have 3 terms, which we do in this green part, we're really only looking at that green part right there. List the multiples of your first and last terms. So, my first term here, and at the beginning, I want you to actually list this out, okay? My first term is 6x squared, and I want you to actually list it out. When you get good at this, you might can do this process in your head, but right now, I want you to list it out. And I want to think, what 2 things could I multiply together that would give me 6x squared? So, for example, I could do 2x times 3x. That would give me 6x squared. And for this, there's one more thing I could multiply together that would also give me 6x squared. We could, in general, go ahead and just split your x's even, and so have an x with each one. So that is true, that would work, but it's not usually going to help us for factoring. So 6x and 1x is the one I would be talking about, although Lanaya is correct that it would also, you could do that, but in general you want to keep them split evenly, unless you got something real weird that we won't see in Math 1. All right, so those are our possibilities for our things we can multiply to get 6x squared. Over here, for our last term is negative 20. Okay? We want numbers we can multiply together that'll give us negative 20. Okay? Negative 10 times 2, or I could do positive 10 times negative 2, right? So basically all of our options are going to have sort of 2 there. What else? Negative 5 times 4, or I could do positive 5 times negative 4. What else? negative 20 times 1, or 20 times negative 1. A lot of times when I list, I don't list these, like I don't list the negatives separate. I just know in my head I can switch them, but if you want. Is that everything? I think so. All right, that's all you can multiply together to get 20. Okay? So, we know whenever we multiply binomials together, when we multiply those first two terms together, it gives us this first term right here. And when we multiply those last two terms together, it gives us this term right here. So what we have here, these are my possible last terms, and these are my possible first terms. And so these can be kind of frustrating sometimes because our next step is guess and check. There are not a lot of things anymore that I just tell you to guess and check on, right? But our next step is to guess and check. So the 2x is going to stay out. Let's switch back to blue. 2x is going to stay out front. This 2x right here that we had here is going to stay right here. Oops, that's supposed to be yellow. All right, we just leave it alone. But what we're trying to do, and you want to do this in pencil if possible, is we want to have two sets of binomials, and we will have, in each binomial, we'll have a first term and a last term, right? So for our first terms, I could either use 2x and 3x, or I could use 6x and 1x. And I've just got to pick one. So Isabella says she wants to do 6x and 1x, so we're going to try it. It might not work. This may not work. We're just guessing and checking. And then my possible last terms are over here. I've got a bunch of possibilities for it. So, what'd you say? 10 and negative 2. So I'm going to do a positive 10, a negative 2. All right. So what we've got to do now is we've just got to check and see if this works. Okay? So if I check, I'm going to multiply 6x times 1x, which gives me 6x squared. I already knew that was going to work because that's why I picked 6x and 1x. Correct? All right, so I already knew that was going to work. Then I'm going to multiply 6x times negative 2, which will give me negative 12x. And I'm going to, so I've distributed my 6. Now I got to distribute this 10. So plus 10x. And then, right here. And then 10 times negative 2 gives me negative 20. Now, I did this first part and the last part in a different color because I really already knew that I was going to get that 6x squared because I picked the numbers that were going to equal 6x squared, right? And then I really already knew that I was going to get this negative 20 because I picked numbers that would multiply to give me negative 20. So all I really care about are those middle terms. I want to see if they work. And if I look at these, if I combine my negative 12 and my 10x, I get negative 2x. Is that what I had for my middle term up here? It is not. So this is not it. So I've got to try something else. Before we give up on this, I would do this. Sometimes it'll make a difference if you switch where the 10 and 2 are at. So let me erase here. So let's put the 2 here and the 10 here. Sometimes that will make a difference. So before I totally give up on 10 and 2, I'm going to try this. So again, the 6x times the 1x is not, it's going to be 6x squared. But the 6x times 10x, that's going to give me negative 60x. Then on the inside, I'm going to get positive 2x. Is that going to give me the negative 7 that I need? It's not. So I don't think 2 and 10 are going to work, at least not with 6 and 1 being my first numbers. Right? So that means we either need to change our 2 and 10 or our 6x and 1x. Negative 5 and 4. Let's try that. So I'm going to erase these here, and I'm going to try negative 5, positive 4. Erase this middle stuff here. Notice that I'm not really erasing what I've done here for the 6x squared and the negative 20x, because that should always be the same. So if I do my outside terms, my 6x times my 4, I get positive 24x, and right here I'm going to get minus 5x. Is that going to give me negative 7? No. We could switch them, and it might make a difference. So I can put the 4 here, the 5 here. That's going to give me 30 and negative 4, also not negative 7. So I don't think the 4 and the 5 will work. Now, sometimes the numbers furthest apart do work, the 20 and the 1. Sometimes the 20 and the 1 do work. So I don't want to tell you not to ever check the 20 and the 1. But it's less likely. I like checking the numbers that are closer together. I think our issue could possibly be that maybe we should not use the 6x and the 1x. So I'm going to back up now, and I'm going to try again with my 3x and my 2x. So I'm going to put a 3x right here and a 2x right here. And then I'm going to pick some of these over here, negative 10 and 2. So let's do negative 10 and 2. All right, so when I multiply those together, 3x times 2 gives us a positive 6x. And then the negative 10 times 2 is negative 20x. That's going to give me negative 14x, which is not it. So I might could switch them just so you guys don't scream. I will tell you that switching them is not going to fix our problem. Think we need a 5 and 4. All right, let's try 5 and 4. 5, 4. Okay, so that's going to give me a positive 12x and a negative 10x in the middle. That does not work. But don't give up. Don't switch your 5 and 4. We're almost there. So 4 here, 5 here. All right, so 3x times 5 will give me a positive 15x. And negative 4 times 2 will give me a negative 8x. What's that give me? Are you sure? It gives me a positive 7. So Haley said, can I change the sign? I can't just be like.
You're negative.
Very good idea. Haley said, what about if we put the negative with the 5 and the positive with the 4? Would that fix our problem? Now, 3x times negative 5 would be negative 15. Remember, I told you we're doing the hardest problem first. And then 4 times 2 will give us a positive 8. That equals negative 7. Hallelujah. We have found our answer. Finally, we've done so much work we may not even know what the answer is. But this part right here is your answer. 2x times 3x plus 4 times 2x minus 5. That is your answer. Okay, now, Keep in mind, I told you guys we were doing the hardest problem first. It will not get more difficult than that. We will have problems. We might have some others that are as difficult as that, but we're not going to have any more difficult than that. Okay? It'll be this or easier. Okay? Let's try to do one more before we go for today. All right, so here's another one. I think this one's going to be a little bit easier. Okay? So same steps as before. The first thing we always want to do is look for a greatest common factor. Does this have a greatest common factor? 2. So I'm going to divide everything by 2. And so I've got 2, and then it'll be 6x squared minus 5x minus 4. And then my goal here is to break this into 2 binomials where I got a first term and a last term in each binomial. So I'm going to take this 6x squared, that's my first term, and for right now, I want you writing it down. First term is 6x squared. We just did that one, right? I could either use 2x and 3x, or I could use a 1x and a 6x. And then my last term over here, to get that last term, which is a -4. I've really only got a couple options here. I could use -1 and 4, -2 and 2. If you want to list it separately, you could use a +1 and a -4. Sometimes I don't even list that separately. I just know I could switch my negative. So these are my options. This one's going to be slightly easier just because you have fewer options you could check. So, Ian, pick our x's for us. 2x and 3x or 1x and 6x? Which one are you going to try? 2x and 3x. So let's try that. 2x, 3x. Okay? Rosalind, which one do you want to try for the last term? The -1 and 4, -2 and 2, 1 and -4. -2 and 2. So -2, +2. Okay? And now we're just checking, right? So we should see our first term should work because that's the reason we picked it, right? 6x squared. And then we're going to do our middle terms. So that'll be plus 4x minus 6x. And then that last term is the minus 4. So did that work? No, that did not give us -5. It won't help to switch where they're at on this one because they're both 2's, so it wouldn't make a difference there. I mean, it would change the sign if we switched the sign, but it wouldn't give us a different number. So I don't think the 2's are going to work. Let's try the 1 and the 4 before we give up on these 2 and 3. So let's put the 1 here, the 4 here. So 2x times 3x is still 6x squared. 2x times 4 is a positive 8x there in the middle. Color for checking. And then the -1 times 3x is -3x. Ooh. We're so close, right? We're getting a positive 5x right now. We need to have this -5x. So I just got to switch those signs. I'm going to make this a positive 1, and I'm going to make this one over here a -4. There, and so when I check now, I'll get a -8x and a +3, which will give me a -5x in the middle. So it finally works. I've got 2 times 2x plus 1 times 3x minus 4. And that would be my answer. And you can check these by multiplying them back together. If you do, you've got to multiply these 2 together first, and then you'd have to distribute that 2 to everything. Okay, we got time for one more. That was less painful, right? Less painful than the one before it. All right, let's look at this next one. All right. We got, okay, for greatest common factor, all we got is a 1. So this is a case where we do not have a greatest common factor. So we're going to go, if you don't have a greatest common factor, you just go straight into trying to factor into your two binomials where you got a first term and a last term. So our first term is 5x squared. What could I multiply together to get 5x squared? 1x times 5x. It's wonderful when this happens because you know those have to be what you use. You could go ahead and write it down, a 5x and a 1x. It doesn't matter which order you put them in. There. You know you have to have a 5 and a 1 because that's the only options. For our last term, we got negative 14, so we could do negative 7 and 2, or negative 2 and 7, negative 14 and 1, or we could do negative 1 and 14. All right, Aiden, which one do you want to try? Negative 2 and 7, so negative 2, positive 7. All right, we're going to check to see if this works. So 5x times x is going to be 5x squared. Then we'll get 5x times positive 7, which is going to give us positive 35x. Is this, oh, this is, I love it when this happens. Negative 2x. Negative 14. It almost worked. I just have, that's a positive 33x. I need a negative. So I just got to switch the signs. So make this one a positive right there, and this one a negative. That makes this a negative 35, positive, negative. Yes. So my answer for this would be 5x plus 2 times x minus 7. I love it when that happens. Sometimes you guess it exactly right, and then you feel like a genius whenever that happens. So we're going to continue this more tomorrow and practice with it some more. Actually, we're going to continue this more like all week, because you need to be good at it. There'll be a few other special cases that we will look at as well. No.